record to this. Okay. Okay. So hi everyone. Welcome to today's EvoAgentX onboarding session, and we are very excited to have you here. Uh, Actually, before this meeting, we already had some uh like progress meeting. So every Sunday to discuss the weekly progression for the EvoAgentX. But this is probably the first formal onboarding meeting that we are going to specifically focus on one module of the EvoAgentX, and we are going to give a detailed introduction for the memory module of EvoAgentX, and we hope the community developer can join us to push the performance of the self-evolution. So in this session, we'll be diving into the memory module, a core component that enable EvoAgentX agents to retrieve and evolve based on the prior experience. Uh, Nowadays, the agent is becoming a very popular and hot topics, not only in research but also in industry. And we know that from our own experience, because how do people evolve, or let's say they become smarter? We need to have some knowledge in our mind. That's why memory is so important for the topic of self-evolution. Because if a workflow or an agent, if they don't have memory, then every time when they get the same query, they are going to generate the same or similar outcomes. So, but if they have memory and they know that if they are going to take some action A, and they have memory that showing that the action A was actually wrong last time, then for this time they can probably take less step to find the right action. So whether you are contributing new features, building workflows, or simply exploring the framework, understanding the memory model is crucial for building more capable and autonomous agents and agentic workflow. So later we will, uh, Jingyuan will give an introduction of the memory module and also the architecture of the EvoAgentX. Then we will walk through the how memory is structured, used, and extended. At the end, we will have a QA session, and during the QA session, we can discuss if you want to contribute some new functions that you fancy about, and what is the next step for the whole architecture. But before we can proceed, maybe uh, wait, let me share some news request. Okay. Mm, okay. Can you guys see my screen? Yeah.
Yes.
Okay.
Yes.
So this is a survey paper, which is Jingyuan is the first author, and many co-developer of EvoAgentX is the author of this survey paper. In this survey, we investigate how the self-evolution algorithm um, is going to bridge the foundation model and the lifelong agentic system. We definitely encourage you to check out our paper, and maybe if you have other thoughts, welcome to send your comments, or if we miss there are already some issues on the GitHub saying that we missed this paper, that paper. So we really welcome if you if you can spot some relevant paper that you think can be a good contribute to this survey, we are going to continuously improve this survey paper. So you can send your comments on, there is a GitHub page for this paper. And if you prefer to directly communicate with us, you can also send on the Discord channel. And I think that's it. Jingyuan, you can host this meeting.
All right, so let me first share my screen. Yeah. Yep. So now you can see, can you see the screen?
Yes.
Yeah, yes.
Yeah, okay, so today, thank you everyone for joining. And today I'm going to give a brief introduction of the memory module in EvoAgentX. So if you are not very familiar with EvoAgentX, I can give you a brief introduction. So EvoAgentX is an open source project uh, that is developed to building a self-evolving AI agent systems. And just as Sue just mentioned, memory is a very important mechanism in this self-evolving loop. So today we are going to give a brief introduction of the current memory mechanisms we have built in EvoAgentX and what is our next step. So here is the outline for today's introduction. So I will briefly talk about the memory mechanism, and after that, I will introduce the existing features in EvoAgentX that is relevant to memory. And the next, I will share some roadmaps and the future plans for the memory module in EvoAgentX. And finally, I would like to hear your thoughts, and maybe if possible, we can invite some collaborations on this memory mechanism. And also, if you have any questions during the introduction, feel free to interrupt and ask. So let's first give a brief introduction of the background knowledge and the whole project. So as some of you may know, the EvoAgentX is an open source project for building a self-evolving ecosystem of AI agents. This framework focused on the auto. There are two focus in this framework. The first one is the automatic construction of agentic workflows. The purpose of this feature is that we want to automatically build an AI an agentic workflow. So we don't have to manually configure a very complicated prompts or workflows. The second feature is the feature of cell evolution. We want to incorporate some existing cell evolution techniques. So these techniques ev can automatically evolve the whole agentic system based on some interaction data and possibly some environmental feedback. These are the two core features of our framework. And the last feature is that we want to make this framework modular, extensible, and community driven. So we would like to invite collaborators from the community to collaboratively build this framework. Yep. So this is the brief introduction of our whole framework. Next, I would like to introduce the role of memory in this in agents. So why is memory important? Because the memory can there are some core features of the memory. The memory can support contextual understanding. This means that we can incorporate some context in the prompt to the agent, so the agent can have a better understanding of its current task situations and better execute the current task. The second importance of the memory is that it also enable cross-task experience sharing and continuous learning. This means that if you have this kind of memory, then maybe you can use the experience from your previous task in the current task, so you can better execute uh, so you can generate better performance. Uh, a very obvious benefit from this is that if you have a successful experience in a previous task, then maybe you can use the successful experience in the current task to obtain better performance. And finally, the importance of this memory is that it provides some personalization capability and also the knowledge accumulation. By using this kind of memory, you can customize your own agent and provide some personalized outputs. Here, I would like to introduce some fundamental concepts of the memory. As some of you may know, there are actually two kinds of memory in AI agents, the short-term memory and also the long-term memory. So for the short-term memory, it temporarily stores the information that is relevant to the current task, such as the recent conversation turns and also the outputs from the previous node in agentic workflows. So in short, the short-term memory only store the information that is useful for the current task. Once the task is finished, the short-term memory will be cleared and it will not be stored in the local storage. The purpose of this kind of short-term memory is to provide some context for the multi-turn dialogues and also some workflow generation or execution. The second type of this memory is the long-term memory. The long-term memory, it will persistently store the information across different sections and tasks. It means that in different tasks, the long-term memory will store some important information from this task in a local storage. And when the system encounter a new task, it will also retrieve some information from this long-term memory that is useful or helpful to the current task. There are some key features for this long-term memory. So first, it can retain some important facts, user preference, and learned behaviors. These this information are proved to be successful in the previous task, and once you have these important facts or something in the long-term memory, you can use them to enhance the performance in the next task. And the second key feature of this kind of long-term memory is that it enables the agents to accumulate new information and update outdated data. This feature is quite important for continuous learning for an agentic system. Next, I would like to provide a brief overview of the existing memory features in EvoAgentX. Currently, there are two core functions in EAX that is relevant to the memory. So the first one is the retrieval augmented generation techniques. The rec technique is the core function for the memory storage and retrieval. It enables the agents to access external knowledge efficiently. In addition to this, there is also a long-term memory-based agent examples. So in this example, we have provided an agent that can store, retrieve, update, and delete memory across different tasks for adaptive behavior. Next, let's go dive into the retrieval augmented generation feature. So the RAG is a core technique for building the long-term memory based agents. It enables these agents to assess past experience and external knowledge. So this figure shows the pipeline for the pipeline for the rec functions. So let's begin from the right. So in order to use this rec function, so first you need to build a vector store. So here we have a build knowledge indexing process. So for raw documents, we use the Llama index reader to process this kind of input, and then use some trunker to trunk these documents. After we have the text trunks, we use some indexing techniques to build the index for this kind of input documents. Typically, the indexing here involves some embedding models, such as OpenAI's embedding models or some transformer embedding models. Uh, After this indexing phase, we have a store that a vector or a graph database that which is used which enables the fast retrieval. So once we have this database, then we can move on. We can move to the left, which is the query processing part. So once we have encounter a query from the user, then we can first pre-process the query to augment the query and maybe remove some unintended symbols. After the pre-processing, we can use the retrieval model to retrieve a set of relevant text chunks from this database. Once we have these retrieved documents, we can additionally incorporate some post-processing steps to process or filter out the actual useful documents for the current query. And then we can generate a set of retrieved results. This is the pipeline of the rec function in EvoAgentX. Here are some key features of the rec implementation in EX. So first, our current implementation supports different embedding models, such as OpenAI embedding models, and also some embedding models from Hugging Face transformers, such as BG or E5 model. We also support like different index types. Currently, we support two types of index. The first one is the vector index, and the second is a graph-based index. So for the vector index, it is useful or intended for the semantic level retrieval and is suitable for the unstructured text. So if your knowledge base is a set of documents or a set of unstructured text, then maybe maybe you want to use the vector index. In addition to the vector index, we also have the graph index, which supports entity and relation retrieval and is suitable for the structure knowledge management. So basically, for the graph index, we inside the loop. So we will extract some knowledge graphs from the provided documents. For example, extracting the entities and also the relations between this entity and store them in the database. And during the retrieval, we will directly retrieve from this graph data and then return a set of entities and relations that is relevant to the query. In addition to the above two features, we also support different storage types such as database or the JSON file. Yep, so we have just introduced the one key technique, the rec functionality in EAX. So the second function that is relevant to the memory in EAX is a long-term memory-based agent. So the current long-term memory-based agent we have implemented is an agent that can store, retrieve, update, and delete information during the multi-turn conversation. So this agent is actually designed for the multi-turn conversation. So you iteratively talk with this agent, and the agent will automatically add your input message into the memory. And when this agent generate a response to your input, it will also retrieve the relevant information from the memory and then augment the input with this kind of memory to provide a better response. Uh, there are some core capabilities of this agent. So first, it can store new information during the conversation, which means that it will automatically add each text you input, and it will also retrieve relevant information from the memory to support current generation. It will also update outdated or incomplete memory items. Finally, it can delete irrelevant or some low value memory. But I think for the first three the agent will handle them automatically, but for the delete memory function, I think the agent will not perform them automatically, but the user need to explicitly call this function to delete something from the memory. Uh, Yeah, and also there are some potential application scenarios for these long-term memory-based agents. So the first application scenario is intelligent assistant. This intelligent assistant can enable the agent to remember user preference over the long term and generate some personalized outputs. It also enables some multi-turn dialogue system. Yeah, maybe there is some typos here. Yeah. The third is that it also enables knowledge management. So you can input your own personalized knowledge to this agent. The agent will store them in a database, and later if you need to retrieve something, you can directly ask this agent to retrieve the relevant information. And finally, maybe it can support the adaptive learning system. So we intend to make this agent to continuously optimize and expand its own basis, so it can generate better response to the user input. We also have some future directions or visions for the memory mechanism in EAX. So the first direction is that we want to enhance the existing long-term memory mechanism in EAX. So we want to enable some automatic memory storage, retrieval and retrieval. We also want to automatically detect some uh, detect some anomalies and filter out the noise. So this is the first direction. And the second direction is that we want to integrate some self-evolving memory approaches. I think just as mentioned by Sway, we have this survey paper, and in this paper we actually reviewed a lot of self-evolving techniques. There are some techniques that is relevant to the memory, so we want to incorporate these memory-based self-evolving techniques in our framework as well. In addition to these two, currently our framework only supports like storing and retrieving text-based memory. We want to expand this to some multimodal data such as image or audio. And finally, we want to build a shared memory mechanism between multiple agents. The current memory mechanism is we have built is for a single agent. So there is room for the shared memory mechanism for multi-agent systems. Yeah, that is also a potential future direction. And finally, here are some contribution guidelines. So if you are interested in the memory module in our framework and you want to contribute, here are some potential guidelines. So first, we have a contribution guideline in the GitHub page. You can click on this link to know more about how to contribute or how to make a issue or pull request. Yeah. In addition to the contribution guideline, here is how we manage the project or contribution from collaborators. So if you want to collaborate, you can just pull our code and then create a new branch. You can develop on that branch, and after you have finished, you can create a pull request. And after we have found your pull request, we can review the code, and if the code is ready, then we can merge this to the main branch. We also have some contact and support guidelines. So if you have any issues during the development, you can directly email us at this EvoAgentX Gmail, and then we are more than happy to help by either replying the email directly or arrange a meeting with you if you want. Yeah. And that's all. So if you have any questions, so feel free to ask. Yeah, go ahead.
I actually have some experience in multimodal retrieval and I wanted to contribute on that side. But I was
Mm-hmm.
wondering, most of the contributions seem to be on personalization and memory during the conversation. So when we're
Mm-hmm.
discussing multimodal memory, are we
Mm-hmm.
talking about images that were shared during the conversation or some external database where we just keep some multimodal documents that should be used during the conversation?
I think we can do both. So for the first scenario, the is that during the conversation, the users might send some pictures, right? And we can store that pictures in the vector database. And the second scenario you mentioned is that we can directly build some index from some multimodal documents that can potentially contain some images. I think we can if I think if we want to go this direction, we can start with the uh, document with multimodal information. That's much easier. And after we have this pipeline for processing multimodal documents, we can further proceed to multi-turn direction with images. Yep. So if you are interested, I was wondering whether you want to like you are more interested in the first scenario or maybe or the third or the second.
Well, since I have a lot of experience in building documents, I could start with that to have a bit of an easier onboarding process. In my PhD, I'm more interested in long-term memory mechanisms, but like learning them slowly, and I'm getting there. So if
Mm-hmm.
I could begin with something, I would begin with something that I was more familiar with, which is multimodal document knowledge bases, and then build up with that.
Yeah, yeah. That would be great. That would be great. If you're interested, then so if you want to start with the multimodal document, then you can start exploring the RAG implementation in our framework. I think in the main features for processing multimodal documents is the RAG component. In the RAG component, we have this index reader, which is basically read information from the
做一个袋子，
doc, and then
只有一个塑料
and then
袋就行，我装下那个红色的那个小盒子，
and then process them
太大了。
into some chunker.
好
So you
的，
can you can you
哎，
can start with here.
这有点脏啊。
Yeah, I can. I actually
对
have
对对，
the most experience in this specific area, so I can start immediately and
行
try
行
to
行，没事儿。
contribute in that way.
Yeah, it will be great. It will be
Yeah,
好的，
great for you
thank you.
to contribute.
Jingyan,
哎，
And
好，
maybe
谢了啊。
Jingyan,
uh-huh.
maybe you can
Yeah.
you can mute Alex. Okay, yeah, it's mute. Uh,
Yeah.
I actually I have some. I'm not completely familiar with the multimodal documents. I wonder how do you build this kind of uh, since it's not generated during the conversation. Let's call it external uh, knowledge base or something. How do you store this multimodal information? Do you use embedding to store the image and maybe some video or something?
Yeah, you have basically two routes that you can go with for specifically images. You can either use OCR to turn that image into text and then basically apply this process right here. Or
Mhm.
you can use the new state-of-the-art methods that directly embed the image itself and then basically retrieve that image and give that image to a model that can process multimodal information, like most of the state-of-the-art models we have right now.
Okay.
Mhm.
Okay.
The retrieval process is exactly the same since everything gets basically embedded into vectors. It's just the chunking and basically first embedding that makes the most of the difference.
Mhm.
Okay.
I actually have a paper I just wrote on this that actually explains the steps of how multimodal and text-based pipelines differ. And I would love to share it if you want to read it. It's available online.
Yeah, that would
Yeah,
be
it would
great.
be great if you can send the title of the paper to the chat so we can explore a bit.
Yeah. So Americ, is that your name? Amer
Yeah, Emre.
Emre, yeah. So yeah, so yeah, it would be great if you can contribute some like multi-modality memories. This is actually kind of our like weak in our current groups. I think I was thinking, uh, I don't know if you how so familiar with our projects. I think maybe we can schedule a separate meeting with you and Jin Yuan or Sui, etc. Some other like in charge of memory mechanism, so we can better introduce of the current structure for you, so you can like get more familiar with the projects. And also, it would be great if you can share some like a short presentation in terms of the current multi-model memory mechanism, and also the we can actually start with a scenario like a single task that could use the multi-model memory to like solve something, and then we can like make a release after we integrate this multi-model memory mechanism, and then adding a more like specific scenario, user case, etc.
Of course, I would love that. I have some case studies and I have some basically comparative analysis, and I would love to share all of that. I have presentations and I have a paper on it. So I'm very available for that.
Are you in our like what's the name? Any of our communication channel?
I
Discord.
think I am, yeah, in Discord, yeah.
Yeah.
Okay, great. Maybe Sway will contact you so we can schedule a meeting next in the following weeks or something that we can have a short chat further. Yeah, great, great.
Mhm.
I just shared the paper I was talking about. It is on ResearchGate as a preprint. For any questions, please don't hesitate to reach out. I would love to answer anything.
Yeah,
Great.
it's great. Mhm.
Uh,
Yeah.
okay.
Do we have more questions from the audience?
I think someone else is going to.
Yeah, I have a question about the long-term memory, and uh, I remember that you just mentioned that the long-term memory uh, will record the preference of the users, and but I don't know how the systems interact with the users or uh, require some feedback of the user. So how can the system store the preference information of the users?
Currently the interaction way for this long-term memory-based agents is through multi-turn conversation. So when you start this agent, then you can communicate with this agent, and once you have sent an image, and behind the loop, the agent will try to use some prompting techniques to analyze the input text, and then maybe we can use this text to update outdated knowledge, or and store this knowledge as a new knowledge. Uh, After you have storing this into the knowledge base, once when the agent need to generate some response, it will automatically retrieve some relevant information from the database, and then put this relevant information in the generation prompt, so the agent can generate some response based on your past conversation. That is how the current agent handled user preference. This technique is relatively simple, but we can have some more like advanced techniques to better handle the user preference. That is also one of the features that we are currently developing.
Okay. And uh, there was another question, and I just want to know if we store the information in the long-term memory was in the form of a text or a graph.
Mm,
So when we retrieve the information, we have to retrieve the text or some notes.
mhm. Uh, yeah, I think the current choice is based on based on your own choice. So when you start this agent, I think there is a parameter where you can control how you like to store the index. You can specify that you want to store this in the form of text or in the form of a graph.
Oh, okay.
So, do we have any user case for the current memory mechanism in our EvoAgentX?
I think there is an example called under the examples folder called example with memory action.
Yeah, I mean, maybe next time if we want to present something and we can even like play with the examples so people better understand how to use that and in what scenarios it might be helpful.
Yeah, sure.
Yeah. In
Uh,
general, it's good. Mhm.
mhm. Yeah, in addition to the long-term memory-based agents, there is also some examples about the rack functionality. So you can go to the examples folder and find this rack example to have a better idea of how the current system works. So do we have more questions?
Hi. So, I don't have much idea on RAG or memory management, but when storing an image, is it possible that if we analyze the image and store the information of the image rather than the image itself?
So you mean after once we have stored the image, then sorry, I didn't hear clearly.
Sorry, let me repeat. So, I'm saying that instead of storing an image and using it again, rather we can store the analysis of the image. Like right now, we have a very competent analysis. So if we able to store the information of the image properly, we can use it like the further for the context of the agent.
I think
So,
in the more complicated long-term memory based systems, I think you can store both. You can store both the image and also some analysis results of the image. And when you retrieval, you can do some hierarchy retrieval and where you first retrieve based on maybe the analysis results, and finally you can go to the final pictures.
I think you can also do some metadata filtering in that process to basically find relevant memories and then filter relevant images as well.
Yes.
So we can do both.
Yes.
Mm, do we have other questions? Not just about the memory. If you have any issues about the EvoAgentX, you can go ahead and discuss with us. I've also shared the link to the example that Jingyuan just mentioned in the chat. So if you want to play with the memory function, memory module before the next meeting, you can click the link. Yeah, maybe we need to put something in the README page about how to use the memory functions. Okay.
I actually remembered I had one more question about long-term memory.
Mhm.
Uh, in some of the papers I read, they actually had a separate function to just resolve conflicts between what was in the memory before and what is currently trying to be written. So basically, if the short-term memory is conflicting with some long-term memory, how do you update it? How do you decide which one is actually correct and which one is actually a mistake and anomaly? Do you plan to basically separate that as a new function, or should the update function basically resolve conflicts and then update the memory itself?
Uh, I think in the during the update function we should the agent should resolve the conflicts. Currently we just directly replace the old ones with the new information. But just as you mentioned, this conflict resolving I think is quite important, and we actually do intend to further develop this kind of feature.
Just to chime in here, I think we have one student is working on these kind of memory updating like strategies, including when to update, how to update, and like how to build a feedback loop so that the memory could be updated as per the evaluation matrix. But this is something was not quite uh, mature in the research domain, so we're still investigating some different methodologies. So it's basically like a self-involving process. The memory mechanism here we are building is just like a human beings, right? We learn from the environment and then we update something, and then we need to decide which like episode need to be replaced with the new memory, because given that we assume that the memory size is always limited, right? So yeah, this is something quite interesting. I think hopefully we can have some updates in probably in 2 weeks, and then we can incorporate into the framework. But also that's quite aligned with the multimodal ones, right? I think there'll be even more challenges in. I don't know if like Amber, do you receive any like read any papers that about these things? Also happy to share if you can.
For long-term memory, I think the most interesting paper I read was this one, but I've never heard of any paper combining basically both episode memory and multimodal memory.
Yeah, yeah.
But for long-term memory, I thought this was one of the best papers I've read. It was called MemOS. It's a very long paper, I'm sorry. But I thought it was very interesting.
Well, that's a quite new paper. Yeah, thanks for sharing. Yeah, and I noticed recently there's a MemoryU, which is also open source ones. Is all about personalization. I will also share into the chat. Maybe can keep an eye on their progress. Yeah. Okay, great. Do we have any more question? If no, maybe we can close the meeting, and thank you everyone for joining the discussion. It's very helpful. Yeah, thank you and see you next time.
Thank you. Thank you for the presentation.
Thank you for joining. See you next week.
Of course. Have
Bye.
a good day.
See you.